if there's any other uh, Linux pilots that are or people interested in aviation. That's what this project originally started on, but it has grown into a, I saw the need for many other applications that can use this. So um, that's where it came from me was being a pilot and a software developer and a Linux user. Um, so let me get to the next slide here. So TronView, like I said, started with aviation. The idea behind it was to interface with different avionics and devices related to aviation and creating custom graphical interfaces for it. Um, that included EFIS units, which are what you see in modern aircraft that contain like air data, altitude, uh, just AHRS information, stuff like that, traffic, engine, and then displaying it in a custom UI. And now in recently development, doing augmented reality for that. And I'll get into that portion here later. And then being able to use it also for other purposes like IoT and Meshtastic, which is a recent development for it. Here's some examples of using it in the aviation world, being able to pipe different sources of data into it and then showing your custom view on a screen. There's also a HUD example in the bottom right there. In the automotive world, it's been used. This is an example of a old military vehicle that from the 70s that didn't have much engine information or anything else like that, mostly all analog, and being able to tap in and have kind of a more modern display and engine data metrics. And then Meshtastic, which I'm not sure how many people are familiar with, but it's by by their definition, decentralized mesh networking protocol, often used for off-grid type of communications. And so it just made sense to be able to add that in this project so that private pilots or other people using this can communicate to each other or have set up separate nodes and just seeing all their information in some sort of custom view. Also have added touchscreen support. So at least in the Raspberry Pi world, there's several different touchscreen options and creating and supporting that in whatever type of view you have. And then the augmented reality, um, this is something that's pretty new to aviation. Haven't seen a whole lot of it, but it kind of just made sense as the next version of what I wanted to do with this. Being able to see everything um, instead of a 2D map view, being able to see it in real time where things are based on where your head position is. Uh, so it runs on Linux, of course. Otherwise, I wouldn't be here. Um, but the focus has been on mobile Linux, um, even though desktop, obviously, there's no restriction in it. And it also runs on Mac OS X, which sadly I do most of my development in. But it's yeah. So like I said, the main focus has been on the Raspberry Pi, but there's been other Linux platforms that it also supports. The system architecture written in Python, mainly just to get a an easy user base of or a easy entry point for people to jump on board. Python, of course, has great cross-platform support. Using Pygame for the 2D development and using Panda 3D for the 3D. Uh, this is the overview of the system architecture for it. Um, on the left, we have the inputs, and I'm going to dive into each of these sections uh, in a little bit here, but we have the inputs, which could be an EFIS unit or a Stratix or some sort of gyro or IMU or temperature sensor. Then we have the data ship, which is kind of our data store of all the different collected information coming from the inputs. Then we have the screen engine and the screen um, editor and how all the different screens are designed and stored. And then we have these screen modules, which are independent from the input data. They don't need to know how the data got there. They just know that the data is in there, and now you focus on how do you want to display that data. Um, the application lifecycle uh, is pretty simple. It starts up, initializes each of the inputs that the users define that they're interested in loading. Then we go through the screen initialization, load up the screen, um, and load all the individual screen modules. And then we just start the main loop, which processes all the different inputs that's running on a separate thread. And then it goes through each of the screen modules that the user has loaded and gives each of them a slice of time to run. Then processes inputs and does it all over again. So I'm going to dive into the input section here. For inputs, again, it started with the focus of aviation, so a lot of these are aviation related. Um, but we're seeing over here on the left side, we got like a Stratix box, which outputs ADS-B over Wi-Fi. It uses a UDP protocol. That's also what this device here, right above it, does, but it also gives you some air data and some other information like that, which is nice. We have gyros, we have EFIS units up in the top right. So these are all by different manufacturers like Dynon or Garmin or MGL, and they all output in different formats. So an input coded in Tron view, its purpose is to read in the messages from whatever the external data source is and then save it to a common format. And that goes into this, what I'm calling a data ship. So this is the live data that's coming in from an input source, and it's it stores the information in a uniform known data format so that we can all agree on a universal format like inches or uh, Fahrenheit or whatever. And then the actual output to the user, they get to dictate how they want to see that data. Um, and so there's GPS types of data stores, there's IMUs, which are gyros, there's air data, engine target information, which is like geolocation. And inputs also track their errors if there was any error reading the input so that the user can see that type of information. Now we'll dive into the screens. So a screen is just a JSON formatted file, contains all the different screen modules, their positions, um, and sizes and any other custom functionality that has been available for that screen module. We have templates for these, and then there's a nice editor that comes with this so that you don't have to edit the screens in raw JSON. The screen engine itself, um, it's uh, it's been pretty optimized. There's still work that probably could be done, but it just cycles through, finds the screen modules that are loaded, and runs the draw method for each of them. And then hands off different information like if there was a mouse click or a touch click. Um, and yeah, that's the okay. So then the editor version is essentially the same as the player. It's just adds some extra functionality to let you click and drag and move things around, save your screens. You can view frames per second for figuring out where all your time allotment's going. And then the last section here is the screen modules. And this is what the user really interacts with. Um, so we have several of the screen modules already created, some of the real basic ones like text and gauges and a target scope, which is essentially just like a 2D kind of top-down map view. Um, there are artificial horizons, play controls, images, 3D. We just recently added video input, so that's kind of a new development and depends on what your use case is. But in aviation, maybe you want to have a video of what's behind you or in some sort of view that you can't see. Um, yeah, and so that's the basic. Okay, yeah. So here the install process. Just try to make this as simple as possible. Um, with a simple one line uh, curl command that just runs in your terminal and goes and grabs everything and does what it needs to do. And then ultimately you should just get this startup menu when it's done running. Um, the startup menu lets you go through and configure all the different inputs and gives you some demo options. Inputs, depending what type of input it is, could be setting up your serial port, your baud rate, stuff like that. There's I2C connections for different type of inputs. So it can sometimes be a complex setup to go through that, and that's what this menu here is designed to help you with that. Um, there's to get up and going quickly, there's an amount of demo data that I've put with this so that you can just um, simulate different scenarios and just see examples of different screens right off when you start running it. So you don't have to go and hook up all your hardware and try to get this working. It's nice to just see results right away. So this is a screen of the different inputs that you would go through and select when you first run it. And then for a quick start, you can just go into one of the demos and select one of the demo data of different flight information. This would be an example screen of some data that you could see right away, showing traffic and when you play it back, you would see the aircraft actually flying through and traffic moving around. Um, This is another screen that we have. There's all the different templates that you can jump through and and load as you're either playing live data or playing back old data. Um, and so this is the 2D top-down view showing ADS-B, which is what most aircraft, all commercial aircraft have it, but um, most private pilots have ADS-B on board now. So you can uh, connect to that via Stratix is the most common open source solution. I would like to plug in a new input source, being able to pull that from the internet so that, if you don't have a Stratix box, being able to still see that information. Um, And then here's another example screen that it comes with, just showing you the raw data coming out of the data ship objects. So this can be useful for debugging or whatever your purpose is if you just want to see the raw data. In the editor mode, when you jump into editor mode, just by hitting E, you get uh, a nice interface of just being able to move things around, resize them by clicking on each screen object, the screen object defines what options it has available for the user to manipulate. And so here's an example of a traffic scope and being able to enable showing the call signs, setting the offset of where the data is showing, the scale for it, And so each screen object gets to define all that. For showing data ship variables in the interface, we um, try to make that as easy as possible too, because there can be a lot of data depending on your input sources. And so just giving a nice graphical interface of being able to cycle through all this kind of like a some sort of picker. Screen templates, here's some examples of some of the screens that it currently comes with. Open to, as people add new screens, it's always nice to like add those in here so people have some sort of starting base. And then they can go and modify it. And when you save it, it asks you to save, what name do you want to save the new screen as? For augmented reality, this is currently what I'm using. It's an X-Real uh, glasses with HDMI input or just an HDMI plug. And then I've added an IMU to it that is talking via I2 squared. So this is the current prototype for using it, and this may be changing, but this is working pretty awesome. Being able to um, move your head around and then control the camera view in the 3D environment, um, which I have a screenshot here as an example of that. Um, the terrain data is coming from the space shuttle telemetry data. I think this is 30 meter. Um, every 30 meters, we have an altitude point. And this is just showing a screenshot of some local traffic in the area. And so as you look around, you can see um, where it is. And if there's nothing on the screen, it will show you an arrow to where the nearest traffic is. Um, it also currently working on showing airport information like um, uh, just where the airports are located and what the different distances and all that kind of information. But I think the first thing that I really wanted to show was just being able to do traffic. That was kind of an easy low-hanging fruit to add. And yeah, so then the roadmap, working on adding more AR functionality to it. It also shows metastatic nodes in that view, but I think being able to customize that view and uh, showing more pertinent information is probably the next step for that. For the 2D map, showing streets and rivers, I think is kind of the next function of that. More meshtastic support. Right now, there's some very basic canned messages that you can send through the interface, but I think making it more so that users can put in their own messages and type back and forth or other metrics. Live weather information that's coming soon. Being able to show that for pilots is always a useful thing. Um, Internet-based ADS-B information, like I mentioned earlier, so that if you don't have any hardware that shows you this, being able to just connect to some sort of online API and showing this. CAN support for vehicles. Um, Modern vehicles have usually a CAN bus. There's also avionic or new aircraft engines that use CAN information that would be nice to show. And then more IoT devices like pressure sensors and temperature sensors would be easy to add, and kind of building that community out so that uh, whatever your use case is, you could just plug in the sensor and being able to show that. Tronview.org is how you find us. We have a Discord server and active GitHub. And that was it. Is there any questions?